Today we are going to look at solving some more complex equations. Right? When we were looking at equations before, we were solving basic 1 and 2 steps, which you should have seen prior to this class. Today we might introduce some more complex ideas around solving equations. Some of them you may have seen before, some of them you may have not. Now, the idea behind solving these equations is still based on the idea that we want to do order of operations backwards. We're always doing order of operations backwards, PEMDAS backwards. However, there are some different steps you can use that can help you. These steps that we're going to go through are not set in stone. These are not rules that if you don't do this order, you're wrong. These are rules that you can use if you're not sure what else to do. So I always tell my students one of the first places to start is to get a problem cleaned up and simplified if you can, which means if you see parentheses, it's going to be a good idea to distribute. Okay, I hope at this point we know that parentheses and distributing tell us that if there is a number in front of the parentheses, we are going to multiply that to every single term inside of the parentheses. So I'm going to take 4 times x, which gives me a 4x, and I'm going to take 4 times a -3, which gives me a -12. Right, you could continue solving that. We're not going to do that now, but if you see parentheses, it is a good idea to distribute and get rid of those parentheses. The second way that you can clean up an equation is that if you see like terms, you should combine them. Okay, so if there are any like terms, we want to combine them. Like terms are things that either are the same variable or are both constants. So they have the same letter or they both have no letter at all. So for example, 6y and -3y both have y's, so they can be combined. The key when we are combining like terms is that we always want to use the sign in front of them. So this is a positive 6y and a -3y. A negative and a subtraction are the same thing. So this says 6y minus 3y, which gives us 3y. Right? And then we have a -5 and a +4. So we have a -5 and a +4, which will give us a -1. So this would simplify to 3y minus 1 equals 21. Again, we should be able to solve that from there. That was something you should have known before we started this class. Step 3 for today only we are going to skip. We're going to come back to that later. So we're going to jump down to step 4. We just don't want to have to retake all the notes tomorrow. If there is a large fraction, okay, so with a large fraction, I am calling something that has 2 or more things in the numerator. So if we look at this fraction, right, there's 2 terms, a b and a 5 in the numerator. Our goal is going to be to get it by itself and then to multiply by the denominator. Which means I want to find the things that are in that fraction. So here's my big fraction. That 6 I did not highlight, which means that 6 is what I want to move first. So I want to undo subtracting 6 by adding 6. And then we'll deal with that denominator of multiplying by the 3. All right, and you should be able to solve from there because, again, we talked about that previously. Hopefully, if you kind of get everything simplified and everything cleaned up, you should be at a point that you can do our basic operations where we can undo any addition and subtraction, or we can undo any multiplication or division, which we should already know how to do those steps, so those should be pretty straightforward. So let's go through here and look at a few examples that have multiple steps and some weird things that we might come across. Okay, so our first example here, right? 4 times the quantity of 3y minus 5 equals 20. So I know a lot of my students are going to say, I just know where to start and I know how to solve that, and that's great. If you say, I'm not sure what to do, then if we go back to our steps, step 1 says if there are parentheses, right? This does have parentheses, so we want to distribute. So we're going to pass that 4 out. right? I'm multiplying that 4 to both terms. It then says if there are any like terms to combine, right? I don't see multiple variables. I don't see multiple constants, so there's nothing I can clean up there. I don't have any large fractions. I'm just moving my way down my steps, but I do see addition and subtraction. So addition and subtraction is what I'm going to want to undo next. So I'm going to undo subtracting 20 by adding 20. Now, one of the things that we are going to have to get used to that really throws my students for a loop is what happens if I don't get a whole number as an answer? What happens if I get a fraction? Guys, you can totally get fractions answers, right? So we'll undo multiplication with division. You can use a handheld calculator. You can use the Desmos calculator, whatever it is you want to use. You cannot round your answer. So if you type this into your calculator, 40 divided by 12, it will give you an answer of 3.333333, which you would need to write 3.3 repeating. Now, the other way that you could write this, right, is to hit that fraction button over on the side of your Desmos calculator, which will change this into 10 over 3. You could also write it as a mixed number as 3 1/3. Any of those would be fine. So just understand when you're solving, no rounding. Okay, give me exact answers. Okay, so if we look at our next one here, right, we see parentheses. So parentheses tell us we are going to distribute. So this is going to give me a negative 3x, right? Negative 3 times positive 5 gives me a negative 15. So I'm here. I do not have any like terms to combine. However, I do have a large fraction. Everything is part of that fraction over here though. So I'm going to go ahead and move that denominator. So I'm going to multiply by 2. So it's going to give me a 34 equals a negative 3x minus 15. Right, then I'm going to undo any addition or subtraction. So I have subtraction happening. So I'm going to add 15. I'm going to undo multiplication with division. Again, if you type this into your calculator, it is going to give you a repeating decimal. It's going to give you 16.3 repeating. Well, negative 16.3 repeating. If you write this down, you could write negative 16.3 repeating. Okay, but you can also just reduce the fraction. Negative 49 over 3 is fine. Negative 16 1/3 is fine. Any of those forms are fine. Okay, our next one is one that is a very common mistake that students make. They see the parentheses and they know that they want to distribute. They just go a little bit too far and they start to distribute this too. The thing that we have to understand is when we're distributing, we want to distribute what's directly in front of the parentheses. So directly in front of the parentheses here is a negative 1. Right? We don't see that 1 there, but there is really a 1. So I'm going to ignore this 2 for a second, and I'm going to distribute this negative 1 out. So I'm going to make this a negative 3c. A negative 1 times a negative 4 is a positive 4. I'm going to bring that 2 straight down. Okay, then I do have like terms I can combine. I have a 2 that I can combine with a 4. I'm just going to write the variable first because that's what I prefer. So I'm going to write a negative 3c, a positive 2 and a positive 4 gives me a positive 6. Okay, I'll undo addition with subtraction. And then I'll undo multiplication with division. Again, feel free to use a calculator at any point. If there's something like math-wise you need to double check, that is totally fine with me. So our next one is the first one we've looked at that does not have any parentheses. Totally fine, right? So we don't need to distribute, but we do have like terms that we can combine, right? We have a 10a and a positive 2a. They both have an a, so we know those go together. So 10a plus 2a will give us a 12a. And then I have a negative 7 minus 5. So if you are not good with negatives, pick up your calculator. Handheld calculator, Desmos calculator. All right? This is going to give us a negative 12 equals 12. Apparently I decided I like 12s on this problem. Right, then we're just down to a two-step equation, so we can undo our addition and subtraction. And we can undo our multiplication and division. We'll get a equals 2. Our last problem here is technically a two-step equation, and this is one that some of you might be completely comfortable solving. We're actually going to look at a couple approaches to do this because I want you to have some options when you're dealing with fractions. So option number one is that you can straightforward treat this like a two-step equation, right? This is really no different than saying 2x plus 7 equals 13, because we would all agree that we would undo adding 7 by subtracting 7. The only difference here is that we're undoing adding 7, 6 by subtracting 7, 6. Now, my guess is that several of you will need to pick up your calculator, which is completely fine. Okay, so if you need to pick up a calculator and you need to type in the 13 thirds minus 7, 6, whatever it is that you need to do to get that figured out is totally fine with me. So that will give us 2x over 3 equals 19 over 6. Right, then just like normal, we'll undo division with multiplication. Now again, you might need to pick up your calculator and take 19 6 times 3. Those 3's cancel out. That will give us a 2x equals a 19 over 2. If you're working with a mixed number, you could use a calculator as well. If you're working with a like, it's all fine. All right, then we'll undo multiplying by 2 by dividing by 2. Again, use a calculator if you need to. And we'll get x equals 19 over 4. So whether you write that as an improper fraction, a mixed number, a decimal, any of those options are fine. Now, the other option that I want to show you, which I know some of you were using when you were doing some of these equations before, right? You might look at this problem and decide you want to get rid of the fractions altogether. So you might say, I really just hate that these are fractions. So what you can do is you can look at these and you need to find what their common denominator would be. If you're like, I don't know what that means, this might not be the route for you, right? But these would have a common denominator of 6. And what you're gonna do is you're gonna multiply this entire equation by 6. Now what throws some of my students off is they're like, well, I can't type this in a calculator. You're right, you can't. So again, this might not be the route for you if this doesn't work well in your head. Excuse me. But what you can do is you can take 6 divided by 3. 6 divided by 3 is 2. 2 times 2 is 4, so this gives us 4x. 6 divided by 6 is 1. 1 times 7 is 7. 6 divided by 3 is 2. 2 times 13 is 26. Now again, you have to make sure you're distributing this all the way through. And then you can solve this just like a regular equation. And you will end up at the exact same answer.